Welcome to this video. In this example, I'm going to show you how to create approximations for the output responses using sampling fit. In this example, we have first run a screening DOE to identify the key parameters. An ARM model is used for this tutorial. The ARM is clamped at one end and under an axial loading on the other end. It has been meshed and modeled in HyperMesh and analyzed using OptiStruct. The design can change shape in 9 different regions, and there are 3 output responses: volume, max von Mises stress, and nodal displacement of the node where the force is applied. So we're gonna go to HyperStudy to perform sampling fit approach to this example. But first, I'm gonna explain a little bit about sampling fit. A sampling fit is a combination of a space-filling DOE method and mathematical model trained by the data generated. It samples the design space and builds a fit model until the required R² is achieved and/or the maximum number of evaluations is reached. It provides more straightforward ways to build fits. The methods here are selected by default: MELS as a space-filling DOE and FAST as an approximation method. So now let's open this example in HyperStudy. From the Explorer, we are going to right-click and select Add from the context menu, and we are going to select Sampling Fit, and we're going to select any previous approach for definition from, and we're going to click OK. We're going to go to Setup, and we are going to clear radius 1, 2, and 3, because these ones have been identified as unimportant parameters, so we can screen them out. Now let's go to a specifications step, and as you can see, MELS and FAST are selected by default. We also have here that the stopping criteria is 0.9 and there will be 2 sampling points per iteration. And there are also going to be 50 evaluations, so this means it will stop when either 50 evaluations are reached or 0.9 for the R² is reached. We're going to click Apply, and we're going to go to Evaluate Task, and we're going to click Evaluate. Here we are going to notice how every time it will sample 2 points, and we can also monitor in real time how the R² value is improved. We need to activate the trade-off tab since we are going to perform what-if scenarios while tasks are being evaluated. So if there is a data point of interest, we are going to add it to the queue for evaluation. Here we are adding 3 points. And here you can see the queue history. And if we go back to evaluation tasks, we can see these points. Here I'm gonna pause the video and resume when it's done. Now that it's done, we can see how it stopped at 50 evaluations, so 0.9 for R² was not reached for every function. We are gonna see that the maximum stress didn't reach the 0.9. Now let's go to the post-processing step, and here we can also see the trade-off tab, and we're going to review what-if scenarios. We can also go to Diagnostics tab, and we're going to click on each label to review the detailed diagnostics of the fit model for each response. Finally, we go to the Residuals tab to review the error between the original output response and the fit for each run of the input and the cross-validation matrix. Thank you for watching this video.